Hello, so my name is Urvin and welcome back to the another session of SQL. Previously, let's see what we had discussed, and then we can move on to the next topics. So, fine. So we saw what was in the agenda, yeah, and we discussed what was the database understood, why is it required, and how it is organized in a structured way in an electronic format. So we understood about what is the database, then why we require a database management system that is to interact with the database. And in this DBMS tool only, we are going to write the SQL queries. Fine. So we understood about database, then database management system. Then we understood about what is a database architecture and the two types of database architecture, that is file server and client server. We understood about this too. So let's just revise the concept. So in here, we understood that a particular file is present in a specific system. It is present, but a person who is using some another system or PC or any type of system, and uh, he will not be able to access a particular file in this system as they are not synced. But still, this file is present here. So if we are using this system itself, then we can use that, right? And then we saw the client server architecture. Here, this was the three-tier architecture which you saw. There can be two-tier and tier architectures which can be present or client and server. So these are the clients who are requesting for some kind of access to the database. They're requesting some data, and that request is processed by the server, and then it interprets this request and sends it to database. Database understands that requirement and it fetches the data, whatever the specific requirement of the data is. It sends that to server, and then server sends back to the particular user who is asking that uh, data, whatever data they are asking for. So let's suppose this user is just asking for finance data, and this user is just asking for HR data. So both of them are going to get different types of data sets, but from the same database itself. Fine. So this was the client server architecture that we saw, and then we understood about what is SQL and why we require this. So it was just a structured query language for accessing and manipulating the database. So this will be used in DBMS tool itself, and yeah, we saw about this too. Then we saw the structured query language, how the installation steps over there for SQL Server, because in the further sessions we are going to discuss about SQL Server itself. So we saw from this link, SQL, you just have to Google SQL Server, and then you have to download the developer edition, not the Express edition. You can download Express edition also, but as you can see that it will just work for small data sets, so small server applications. If there is some size limitations regarding the data sets, that's why I am suggesting you to use the developer edition, because this is a full featured free edition, meaning we can do everything as it is in for a development, whatever features are present in a development environment, that all features are present, just that we cannot use this in a production environment, which is fine because we are just going to study right now, right? We're just going to discuss some stuff, that's it. So it is fine. If you want to in the production environment, then you have to download the paid version, then the free version will not. But for us, for our discussion, this is fine, this is completely fine. So this we had done. We had seen the installation steps, and then let's move on to the next concept. So I will be discussing about the queries and everything on SQL Server. Once I give you a brief about all the concepts that should be understood before going to the SQL Server tools and understanding about the environment there. So prior to that, let's discuss about all the concepts which are required. So first, let's understand what is tables in SQL. So table is a database object which comprises rows and columns. So table, I mean, this is a general term which we have seen, which we have heard from our childhood. So the same concept is applied here also in database. So it is just a database object. So database objects can be anything, column, view, anything that is inside a database can be considered as a database object. Fine. So what is a table? Table is comprised of rows. Definitely rows are there. This particular first row which you are seeing consists of SID department 1, D001 as department number, marketing as the department name. See, this is the whole first record that was seen. Record or a row, both the terms are equivalent. Now, this whole column meaning this SID department, this is the whole column that we're seeing. So this whole column comprises of SID department only. This column that is of department number consists of only department number. This column consists of only department name. This column is just for indexes. Fine. So in this way, a table will comprise of rows or records and columns or fields. Fine. So this is a table. So after database, once we create a database that we're going to see in the next few sessions, then we have to create tables. A table will be for a specific requirement. The examples which I had given previously, like finance department, HR department, so those tables will be different. Here, this is just a department table you can consider. So that's why all the departments are merged here. See, for department number 1 meaning marketing, department number 2 means that it is finance. So this table is just giving you the information about just departments only. This table is not giving information about employees. Employees table will be different. So in employees table, we just see the data for employees itself, nothing else. Fine. So a table is used to store data for a particular requirement only, for a particular topic, or for a particular use case itself. Fine. Yeah. So this is thing which I told you about. Yeah. So this is the record, like I told you, that is the each individual entry of a table, that is called a record or a row, and field or a column provides specific information about data in the table. So what do I mean by specific information? See, department number, this column, this field is just for specifying a particular department name. This field or this column is just used to depict a particular department number. So that's why each column, each field provides specific information. But this whole record is not providing a specific information. This whole record is telling you about the SID department, department number, department name. Three things it is telling you. And more columns can also be present, so a record can provide more information. So that is a table, and these are the records in the fields which are part of a table. Fine. Okay, so let's move on to the next things, that is SQL command categories. So I will be discussing all about the different types of commands which are present in SQL. We are going to implement each and every command which is beneficial in data analytics, that we're going to see definitely. But before that, we should understand the categories, in which all the commands are segregated. So once we know that, then we can easily learn about the different types of commands which are present. So there are basically four types of categories, command categories, in which all the commands are divided. So first, that is data query language, and inside this, under this, there is only one command that comes, that is select. So data query language is useful for extracting the specific data which we want, which we require as per the requirement. So let's say that we just require a particular employee's information whose salary is about 20,000. So this is your requirement, and you just want to extract, or just want to see the output. Extracting meaning you just want to see that output from the database. So for that, you have to use the select command. You will see the examples of this. Don't worry, in SQL Server, you're going to see this hands-on. But just understand for now that If we have some type of requirement that you want to see a particular data as per the requirement, then we use a select command, and this falls under data query language. So in data query language, we can just see the output which we want. You know? We can't manipulate the data or the structure of the table or structure of the database. We can't rename anything. Meaning we can't rename the database, table, column, anything. We can just view the specific data that we require. That's it. Right? Next comes the data definition language. Now, as the name is telling us, data definition language. So here we define the database objects. Now, as you recall, I told you about database object. Object meaning anything that is present inside a database, or the database itself. So the database itself is a database object. So data definition language meaning we are going to change the structure, or we are going to create a structure, or we are going to delete the structure. Structure meaning table or a column or a database itself. So we are going to change the structure, or we're going to delete, or we're going to update, or we're going to create the structure itself, but not the data which is inside. Not the data which is present inside those objects. So we're not going to change or delete or insert the data. We're going to work on the structure, the definition, the schema of that particular database object. So for that, we have to use the data definition language. Fine. Now comes the data manipulation language. Here, in data manipulation language, as the name is telling us, here we have to manipulate the data. So here we are not going to touch the structure. Structure meaning the tables or the database object, like we discussed here in the second part, right? We are not going to change that. We are not going to alter anything. We're not going to drop the structure. We can't do that in this data manipulation language. Here we're going to work with the data inside the tables. So we can insert some new data, we can update the existing data, or we can delete the existing data. Now there is a difference between drop table and delete that we want to see. That we want to see. Right. So now we have covered data query language, data definition language, and data manipulation language. Now let's move on to the last category, that is data control language. So here also the name is telling us that we are going to control the access of the data. See, data is huge, and data is something that if it goes in wrong hands, then it can create a devastating effect. I think some days back only you might have heard news about some data leakage from WhatsApp or from Domino's, that credit card information was leaked. So if some sensitive information is leaked, then it will be a problem for many of the users whose data is present inside their database. So data security is the must. Data security is must. We have to enforce some kind of rules, protocols to secure our database, not just from other people, but from the employees also, because even employees can use that information for themselves and might do something which is not good for the company. So I'm not saying that is going to happen definitely, but we should have some protocols for employees also. Fine. And even for users, so we provide some kind of particular access to particular users and employees. Let's just take an example. Let's say that an employee is working in finance department. So he or she should only see the finance department's information, not the HR department's information or software development department's information, any type of department, whatever there is. He or she should only be able to see the finance department's information. So that kind of grant or that kind of access is provided through queries itself. Even some point and click options will work, that I will show you how we can do that. But we can use SQL queries to remove some kind of access to some particular users, and we can grant some kind of access to them. So this also depends on the access level, the hierarchy. Like manager will have more access, the employees under the manager will have some less access of the database. So this all varies depending on the grades in which they are assigned. Fine. So These are the basic SQL command categories that we have, that is data query language, data definition language, data manipulation language, and data control language. Now, each of these commands you're going to see how we can implement these commands, how we can implement the queries through this, we're going to see. Fine. In the next few sessions, we are definitely going to see. All right. So let's move to the next thing, that is the data types in SQL. Fine. So data type meaning, first of all, let's understand what is a data type. So as you can see, the definition defines the type of data the particular column holds. So as you can see here, SID department is having all the numbers here. Department number is having some string plus string meaning the character, that is the D part, it is a character. And then we have some numeric part also. And department name is just having all the character values. There are no numbers present here. So we can consider that a column will have a particular data type only. So if this column is having integer, let's say that we have assigned integer data type. Integer meaning just the numbers, not decimal part. Integer meaning the whole number itself. Right? It can be minor, it can be negative, zero, or so. If we have assigned an integer data type to this particular column, so if you have done that, we can't insert a value which is having some character value or some decimal value. We can't, because you have already assigned the data type as integer, that this column is just going to hold integer values. So that we have assigned. So that is the meaning of having some particular data type assigned to a particular column. Right? So as you can see here, this column is having integer data type. This department name is having character data type. Now, you will think that what is the data type of department number? So if you ask me, this is the character data type only. Why? Because the character can even have integer also, right? This is alphanumeric actually, but this will be counted under character data type only, right? So to again simply tell you in brief, data type meaning just the type of data which a particular column will hold. That's the data type, right? Now, the different types of data types are numeric, character, which we have already seen. Numeric meaning the integer. In some DBMS tools, it might be called as numeric. Here in SQL Server, that can be considered as integer. Then we have character. Then we also have some date and time data types also. Date meaning just the date that we see, and time, the time which we have normally in our day-to-day scenario. Right? Now, let's understand about the different types of numerical data types that we have. Fine. So int, that like I told you, int is there, but we have some kind of variations depending on the range or the size of the values which you can hold in that particular data type. So the type of numbers will be same. That is going to be the whole numbers, that is 0, 1, or -1. All those things will be there. But the range which it can accommodate will be defined by the data type which we use. So if we just use int, that is also fine. But the range, as you can see, this will be the range. So some limited numbers will be stored. We can store in this data type. But if suppose we have a number that exceeds this number 2147, so if that happens, then there will be overflow and we will not be able to store that value in that integer data type field. So for that, we have something called as big int. So as you can see, the range is huge. We can store so many numbers here, some huge number we can store here because the range is huge. So definitely the size also of this big int is going to be huge. So let's say it may have 8 bytes, int might have 4 bytes. So that depends. You don't have to worry about the size which it is taking. Just understand that it is going to take more size. Int is going to take little bit less size than big int. Small int will just have this much range. Tiny int is again going to only this much range. And this is decimal. Decimal meaning this is the size. S means the size of the decimal, and D means how many decimal parts out of that we are going to have. Let's say that we give size as 5 and D as 2. That means that total there will be 5 numbers, and from that 5 numbers, two numeric field will be after the decimal point. So it can be like 300.26. So in total, there are 5 numbers, 30026, and as we have written, as we mentioned 2 in the D part, that means that 300.26, meaning after decimal place there will be 2 numbers present. So that is the decimal, and this is the range. This is huge, 10 raised to 38. I mean, it is huge. So decimal is having vast, the size range is huge. So if we require if we know that definitely the number size is going to be less, then we can directly use tiny int. No need to use small int or int depending on the size, because then we are just wasting our memory size that we have. So if we know that the number is going to be huge, that can be stored here, then directly use big int, because there will be no chance of overflow in that case. Fine. In that same way, we have some variations in character data types also. So here it is char, and as you can see, the range is 255 characters, so we cannot store more than 255 characters. And if you see this S means the size we have to give. When when I need to discuss about hands-on, char, what is char, and how we're going to specify the data types, that time we're going to see how to specify the size. So when we do that, there will be, let's say we give char size as 10. So we're just telling that, okay, we are using the char data type and we're giving 10 size. We're giving 10 byte space, 10 character space for that particular field. So in some other column, let's say there is an address column. So there we have to give some more space, right? So there we can give 100 or 125 space, depending on us. Let's suppose that we only have a name field. So for that, we can give just 10 characters, because names are small, it is not like address. So we can give just 10 characters. So depending on this, we can configure the size. Now this is interesting, varchar. So varchar meaning variable character. So this is very similar to char, but the thing is that the size and the memory allocation is dynamic here. So just to tell you the difference between char and varchar, let's say that char is having 10 size we have provided here, and I store the value as Urvin, Urvin. It is just taking 5 character space. Then also it is going to utilize the whole 10 characters it is having. It is not going to left the 5 characters for some other values, for some other character values or anything. It is going to allocate that 5 extra characters also. Means it is not going to give that extra space to any other field. So in that way, we can't use that, and there is a chance of memory wastage. But here in varchar, what happens? If we are, let's say that I have varchar as 10, same like char. I have varchar with the size of 10. So here, if I store Urvin, Urvin, only 5 character space will be used, and rest, the whatever the 5 character spaces left, that can be used for some other variable. So in that way, we are being efficient here, and we are saving some space. So that is the benefit of using varchar instead of char. Now text is another data type, and it is storing some huge, it means it is having a huge space size. So it is 65,535 characters. So I mean, it depends on your requirement. If you are having, if you know that you are going to store some huge value in a particular field, and you can directly use text. Now this is easy. This is the date and time data types. So we have the date data type, that is we can change the format, that we will see how we can do that. It's pretty simple. And we have some time data type to store the time, and text that we already saw. Here we can directly store year or month or days, depending on the format you're given. That's it. Fine. So let's discuss the SQL constraint and what is relational database, and what is the design process, and what is the primary and foreign key in the next session. And after that, once we have done that, we will move on to SQL Server, and then we will see how to do all these steps. It is create a database and create a table. We will see all these steps, and then we can move ahead. Fine. So guys, this was it, and let's continue from SQL constraints in the next session. And thank you for your time. I hope you enjoyed this session. So yeah, thank you guys.